Okay, so like I said, 3.5 is all about the roots. Crap. So 3.5 is all about the roots. Now we're going to start by making equations based off of their in behavior. So this is review from 3.1. So first off, all right, if I'm looking at this function, so letter A, what can I say about that function based off of its in behavior? What's true about it? It's odd because they're going in opposite directions. And is it going to be an even? Not even. Is it going to be a positive odd or a negative odd? So think about it this way. If I connect the two endpoints, does that look like it's increasing or decreasing? Guys, that's going up. It's increasing. Yeah. I thought someone said I thought you said I can't hear the fan. Okay. So it is increasing. So that means it's positive. What you can tell also, left side is down, right side's up. Now, what are my roots? So it's -1 and +4. All right, so how would I write them as factors? X plus 1, x minus 4. Now, look at the dance moves now of these two. What's going on? So at -1, what should happen with the x plus 1? It's a bounce, which means that factor should be what? It should be what? Squared. What about the x minus 4? It's a cross, so we just leave it as it is. So, now let me ask you guys this. This is a cubic function. Does anyone know how many zeros a cubic typically has? How many zeros or solutions does a cubic function typically have? 3. All right. That means there should be 3 x-intercepts, unless one of them is counted twice, like -1 is, or we have some that are imaginary. So if we count the number of factors, there's technically 1, 2, because we have to count x plus 1 twice, 3. All right. What about this one? So first off, it's an even function. Is it going to be negative or odd? Negative or positive? I don't know why I keep saying odd. Negative, because it's facing down. So that means my A value should be what? So in other words, this A value was positive. We just didn't know what it was because we don't have enough information for that. So that means this A value should be what? Negative. So we have a negative A of some kind. Now, what are my roots? -1. What else? 2 and 4. So how do I write -1 as a factor? X plus 1. How do I write 2 as a factor? X minus 2. What about 4? X minus 4. Good. Now, look at dance moves. So what's the dance move at x equals -1? It's a cross. So that means we keep it as a exponent of 1. What about 2? What's the dance move for 2? It ain't a bounce. It's still a cross. All right. What about 4? What does 4 look like? It's kind of slight. It is a bounce. So that means x minus 4 should have what? Exponent of 2. Good. Now, if we count the number of factors, there should be an even number of factors. That's why it's called an even function. So there's 1, 2, and then we count x minus 4 twice, so 3, 4. Is 4 an even number? Yep. So that's an even function. You guys see what I'm doing here? How to pull them? Let's try letter D. Walk me through it. What's going on? It's a positive even, which means what about the A value? It's positive A. What are my roots? -3 and 4. So how do I write them as factors? X plus 3, x minus 1, x minus 4. Dance moves. What is it at -3? At -3? So it is a bounce. So that means the exponent's got to be what? 2. What about x minus 1? It's a wiggle, so that means the exponent has to be. It's a wiggle. What's the exponent? 3. And then for 4, it's a cross, so we keep it at 1. So since it's an even function, that means I should have an even number of factors. So this will be 1, 2, 3, 4, 5, 6. Since 6 is an even number, that is definitely an even function. Any questions on just pulling it from a graph? Pretty easy, right? Not too bad. We've already done this. Just review. Now, sometimes with functions, we don't always have real roots. Okay? So do you guys remember when you guys were learning about quadratics back in Math 2, how sometimes if you looked at the graph, the quadratic graph would be way up here, and there would be, and it would not cross the x-axis, meaning there was no solutions. However, what you found out was that it's not all, even though it's no real solutions, what would that mean the quadratic had? What type of solutions would the quadratic have if they had no real solutions? Imaginary solutions. Good. So this would mean 2 imaginary roots. So when it comes to real and imaginary roots, the number of real roots plus the number of imaginary roots should equal the total number of roots. Now, to determine the total number of roots you should have, the total number of roots is the degree of the graph. All right. So what does degree mean? Degree means what? Highest exponent. So whatever the highest exponent is, that is how many roots we should have, whether they be real or imaginary. Now, we can figure out the number of real roots from the x-intercepts. Then we take that number, subtract it from the number we're supposed to have, and that'll give us our imaginary. So let's look at number 1. So number 1, based off of the function, all right, so 3x squared minus 6x plus 5. How many roots should I have total? So 3x squared minus 6x plus 5. What's the degree of that? 2. So how many roots should I have total? 2. So whatever your highest exponent is, that's how many total roots you should have. Now, it's a little hard to see, but we then need to find the real roots. And here's where the axes are. Because again, it's hard to see. So, based off of where the axes are, how many real roots do I have? How many times is it across the x-axis? 0. So that means I have how many imaginary? So I'm supposed to have 2 total. 0 of them are real. So that means how many are imaginary? 2. All right, let's try another one. So number 2, look at the function. How many roots should I have total? 3, because that's my highest exponent. I should have 3 roots total. Then again, it's hard to see, so I'll draw the axes. How many real roots do I have? So how many times does it cross the x-axis? Crosses 3 times. 1, 2, 3. So how many imaginary roots do I have? 0. You guys catching on what's going on here? All right, number 3. How many roots do I have total? 4. Axes are a little hard to see, so I'll draw them. How many real roots are there? 2. Only crosses twice. So how many imaginary should I have? 2. All right. What about number 4? How many should I have total? 5. Good. Axes are right here. How many real do I have? 1. Only crosses once. So that means how many imaginary do I have? 4. Now, look at the imaginary for a second. What's true about all the numbers for the imaginary? All the imaginary numbers are what? They're even. That's actually true. So on the next page, all right, the number of imaginary numbers you should have is always going to be an even number. So additional roots and least degree. So each problem lists some of the roots of a polynomial function, and they're separated by commas. So you're going to state if there must be any additional roots of a polynomial function and give the least possible degree of the function. So here's the biggest thing. Radical roots and imaginary roots always come in pairs. So in other words, in terms of imaginary roots, the number of imaginary roots, there should always be an even number. So imaginary roots, you should always have an even number, including 0. So 0, 2, 4, 6, 8. You should never have an odd number of imaginary roots because they come in pairs. Why do you think they come in pairs? So look at the examples underneath. What symbol is making them become pairs? That plus minus. So remember, we talked about this the other day. Plus minus. This is where it kind of comes into play with the quadratic formula. This can break apart into positive 4 square root 5, negative 4 square root 5. This one can break apart into 5 plus square root 2, 5 minus square root 2. This one can break apart into 3 plus 2i, 3 minus 2i. And these can break apart in positive 3i, negative 3i. So if the root has a radical in it or an I in it, meaning it's imaginary, there's always going to be a opposite sign pair. So if it was originally negative, it becomes positive. If it was originally positive, it becomes negative. That's the other one. It's its pair. All right, so just know that they always come in pairs. So when it asks if there needs to be an additional root, that's typically what they're asking. Is there one with a radical or with an I in it that we need to state what the other one is? So let's look at an example of that. So they gave us two of the roots, 1 and then 2 minus the square root of 5. Is there another root that I need to add on to there that I know for a fact has to exist? 2 plus the square root of 5. Good. So they gave us the minus version. Now we have to have the plus version. So the least degree, how many roots do I have total now? How many roots do I have total now? 3. So remember, these count as 2 different roots. Even though there's a plus minus, it counts as 2 different roots. So that means that this has to at least have a degree of 3. What about letter B? So I got 2, 3, and 4i. Is there another root I need to add? I need negative 4i. All right, because we got the positive version. Now I need the negative version. So how many roots do I have total now? 4. So that's the least degree. So that's how you calculate least degree. It's however many you have total after you add on the additional roots that you know for a fact you should have. So if we have 4i, I know for a fact I should also have negative 4i. Because using the quadratic formula, it's impossible to not have a plus or minus imaginary number. What about C? So I have 5 with the multiplicity of 2. Be careful about that part. And then negative 2 plus I. Not 2 plus I. It's always the sign in front of the imaginary or radical that changes. So it's negative 2 minus I. So guys, the only sign that changes is the sign in front of the imaginary number or the radical. All right, that's the only sign that changes. Now, be careful about this. How many roots are there total? 4. Why is it 4 and not 3? Right. Multiplicity of 2 means count twice. So since 5 is counted twice, that means this is 1, 2, 3, 4. All right. Any questions on that one? Do I need to do any more examples? Are you guys pretty solid on that? All right. Now, let's go into the big monster. All right, before we get into that, take out your Chromebook, get on Desmos, because we're going to need them out. So take out your Chromebook and get out Desmos. You may also want that quadratics packet out as well, just so you have it for quadratic formula reference. All right, my darlings. So all of that lead up was to get us to this part, which is finding all of the roots. Okay? Now, it can be a little tedious, and I know for a fact it's very step heavy. because you have to use a combination of desmos, you have to use a combination of synthetic division, and quadratic formula. There's 3 different things that you have to do in here. And then you have to convert in factor form. All right. So it can be a pain in the neck, to say the least. All right. So now, first off, we're going to look at letter A first. So here's the general synopsis of how you do this for finding all the roots and factors. You find all of the integer roots by graphing, meaning, oh, it's just frozen. Ugh. Unfreeze, come on, unfreeze. There it goes. So you need to find all the integer roots by graphing in a graphing calculator. All right, so that's Desmos. And you write the corresponding factor for each root. So what do I mean by integer roots? I mean no decimals. So if it has a decimal, it's not an integer root, we don't need it. It will sometimes show roots that have really funky decimals. Those are not considered integer roots. All right, those are typically irrational roots that you need to find with quadratic formula because we want them to be exact. Then, once we get at least one integer root, which typically there will be, you need to use synthetic or long division to reduce the polynomial. And you got to divide it by each factor one at a time. Decimals, sorry. Well, my handwriting ain't the best. Now, whatever polynomial results in, it should be a quadratic. That means you might have only imaginary or irrational roots, so that's where we need the quadratic formula. Then we write the final polynomial in its factored form and list all the roots. So, this is very step heavy, but we'll do it one step at a time. And the way these problems are set up, it's actually kind of divided already in the steps. So, first things first, here's kind of where you want to get an idea. Always start by looking at the degree, because that'll tell you how many roots you should have total. So, based off of the degree of this function, how many roots should I have total? How many roots should I have total? 3. So I know I should have a total of 3 roots by the end of this. Now, take a minute and graph 5x cubed minus 9x squared plus 8x minus 20 in your calculator. Desmos, whatever. Same difference. So 5x cubed minus 9x squared. What was it? Plus 8x? Plus 8x minus 20. You may have to zoom out a bit. Now, how many times does that cross the x-axis? Once. So if we click on that, my first root is what? 2, 0. So the root itself would just be 2. So that's my only integer root, 2. So that means, since we have that integer root, and we know for a fact that it is a root, we can then use synthetic division to divide that root into this polynomial, because since it's a root, that means it's a factor. All right. So we're going to divide. Now, since we already have the root, we don't have to worry about setting it equal to 0 to find what goes in the little box for synthetic division. It's just 2. What?
So we're just adding like one more step to it and just doing it the rest of the learn last week.
Pretty much, yeah. Well, that's part of it. You'll see. All right, so we got the root of 2. That goes in my little box for synthetic division. What goes across the top? 5, then negative 9, then 8, then negative 20. Now, since this is a root, that means that our remainder should be what? Since we know for a fact that it's a root, it's a solution, that means our remainder should be what? 0. So if our remainder is not 0, we know we did something wrong. So what's my first step with synthetic? Not yet. Nope. Bring the 5 down first. Then we multiply by what? Multiply by 2, so 5 times 2, 10. Then we add. What's negative 9 plus 10? 1. Then repeat. So 1 times 2, 2. Add, 10. 10 times 2, 20. Add, 0. Now remember, these are just my coefficients. So I have 5, 1, and 10. There should be a plus here, plus here. What variable with what exponent comes after the 5? X squared. Good. Remember, it should always be 1 less than the original degree, because we're dividing. So if you did 5x cubed divided by x, you get x squared. Then you just go down the line. So what goes after the 1? X plus 10. So this is now where we take the quadratic formula. All right. So this function right here is where we're then going to use the quadratic formula to find the other roots. All right. So just so you have it on the page, the quadratic formula is negative b plus or minus the square root b squared minus 4ac all over 2a. So what's my first step with quadratic formula? Before I even put in the formula, what should I do? So I have 5x squared plus 1x plus 10 is equal to 0. We don't have to move anything around. So what's the only thing I got to do first? List A, B, and C. So A, B, and C. What's A? 5B, 1C, 10. And now I can put it in the formula. So I have negative 1, because that's B, plus or minus the square root of 1 squared minus 4 times 5 times 10 all over 2 times 5. So now let's do some simplifying, specifically underneath the radical. So this would be negative 1 plus or minus. What's 1 squared? 1. Negative 4 times 5 is 20 times 10, that's negative 200. All over, what's 2 times 5? 10. Now, what is 1 minus 200? 1 minus 200? Negative 199. So this would be negative 1 plus or minus the square root of negative 199 all over 10. Now, I'm pretty sure 199 is a prime number, but there is one thing we do have to do to simplify the radical. We have to take out the I to get rid of that negative. So this is negative 1 plus or minus the square root, or I, square root 199 all over 10. And since these top two are 1, there's no more simplifying. So this is my other 2 roots. So remember, this is 2 roots right here. Now, we're going to list out all of our roots. So our roots are x equals the set of 2, comma, -1 plus I square root 199 over 10, and -1 minus I square root 199 over 10. So those are our roots. And remember, I included the one that we just found at the beginning. Now, factored form. What is 2, a root of 2 as a factor? What's a root of 2 as a factor? X minus 2. Now, for these roots, there's not much that we can do for writing them, but if we go up a little bit, what could I possibly write that I know that after I use quadratic formula, I would get these roots, but it may just not be a nice binomial factor? What could I write? I'm kind of already have it on the board. So guys, you're going to take this quadratic, and this is your other factor. Because isn't that what we use to find the other two roots? Right? So this would be, our other factor would be 5x squared plus x plus 10. So that's what you do. If you have imaginary or irrational roots, you just take the quadratic that we use to find those roots and write that as one of your factors. So that would be the function in factored form. Don't try and convert these imaginary numbers to factors like x. Like, it's just, don't do it. It's messy. All right, any questions on that one? Now, that was one where, it was fairly simple. We only had to do synthetic division once. But that's not always the case, guys. Shh. But that's not always the case. Sometimes we got to do it more than once. So let's look at this next one, letter B. So with letter B, shh. Guys, stop talking. So with letter B, first off, look at the degree. How many total roots should I have? 5. Ladies, stop talking. So we should have 5 total roots. All right. So we're going to go ahead and put this into Desmos to get hopefully a couple of integer roots. So this will be x to the 5th plus x to the 4th. What is it after that? Minus 2x cubed. Then minus 14x squared. Then plus what? Plus x and minus 15. Oh, this is the one with this one should be a plus 15. I forgot. That's typo. There we go. So it should be plus 15, not minus 15. That's a typo. I think this was supposed to be a... Hold on. I know there's a typo in here. I just got to find it. Give me 1 second. Okay, that's the typo. Okay. All right, so here's the typo. I was wrong. It's not the 15 that has to be positive. It's the negative 14x squared that has to be positive. So guys, here's what it should be. So this 15 should still be negative, but this 14x squared should be positive. So it should be, that should be positive. The 15 should be negative. My bad. So it should be x to the 5th plus x to the 4th minus 2x cubed plus 14x squared plus x minus 15. So everyone got that? Now, if I click on all of the roots, what are my 3 roots that they gave me? -3, -1, and 1. So I'm going to list them here. So -3, -1, and 1. Now, here's the fun part. We have to do synthetic division using all of these roots until we get a quadratic. So in other words, we're doing synthetic 3 times. All right. So it doesn't matter which root you start with, but you're going to only use every root once for each time you do synthetic division. So I'm just going to go down the line. So I'm going to start with -3. So what goes across the top if I'm using -3 as my root? So it's 1, 1, then -2, +14, 1, and -15. Now, it is a root, so that means that my remainder should be 0. If it's not, then we have an issue. So I'm going to bring this down. I have 1. What's 1 times -3? What's 1 times -3? -3. 1 minus 3? -2. -3 times -2? +6. Add them together. 4. -3 times 4? -12. 14 minus 12? Right? -3 times 2? -6. So that'd be -5. -5 times -3? 15. Add those together. 0. So what would be my first exponent for this round? 4. So this will be x to the 4th, or 1x to the 4th, minus 2x cubed plus 4x squared plus 2x minus 5. Now, I then got to do synthetic division again. So I did it with the first root. Now I'm going to do it with the second root using the new function that I just got. So I have -1 in the corner, and my coefficients should be the exact same thing that I have down here. So 1, -2, 4, 2, -5. And same thing, my remainder should be 0 at the end. So bring it down. I have full faith that y'all know how to do synthetic division, so I'm going to do this quick. So 1 times -1 is -1. -2 minus 1 is -3. -3 times -1 is +3. 4 plus 3 is 7. 7 times -1 is -7, so that's -5. -5 times -1 is 5. Add them together, 0. Yes, ma'am. Okay. Now, since our previous one was degree of 4. What should our degree be for this function? It should be 3. So this will be 1x cubed minus 3x squared plus 7x minus 5. And then we got to do synthetic one more time. All right, so we did the -1, so that only leaves us with the 1 to do. So in other words, you're dividing every root into that function until you end up with a quadratic. So you don't stop until you end up with a quadratic. So we'll do 1. So this will be 1, -3, 7, -5. Again, should get a remainder of 0. Bring down the 1. 1 times 1 is 1. -3 plus 1 is -2. 1 times -2 is -2. 7 minus 2 is 5. 1 times 5 is 5. -5 plus 5 is 0. So what's my final quadratic? What should it be? X squared minus 2x plus 5. And I'll throw the 1 in front of there since we had it. So this is where we stop doing synthetic. All right. And then change into doing quadratic formula. All right. So now we got to do quadratic formula to get those last 2 roots, which are most likely going to be imaginary because it only crossed the x-axis on the graph 3 times. All right. So ABC, what is it? 1, -2, and 5. So if I put it in the quadratic formula, I have a negative times -2 plus or minus the square root of -2 squared minus 4 times 1 times 5 all over 2 times 1. Haven't done anything else besides putting it in the formula. Now if I do some simplifying, negative times negative is a positive, so this is +2 plus or minus the square root of 4. -4 times 1 is -4 times 5 is -20 all over 2. What's 4 minus 20? -16. This will be -16 all over 2. Now, what's the square root of -16? 4i. Good. All right. So we have to take the I out. So we have 2 plus or minus I square root 16 over 2. And we know that the square root of 16 is 4. So this would be 2 plus or minus 4i all over 2. Now, the radical's gone, but since we have the I there, we can't really separate it. But can't I simplify those 3 numbers? Yes, I can. So what's 2 divided by 2? 1 plus or minus 4 divided by 2? 2i. Now, since I just divide both these by 2, that means this is gone. So I don't have a denominator anymore. So this right here is my other 2 roots. So if I list out all 5 of my roots, x should equal -3, -1, 1, 1 plus 2i, and 1 minus 2i. And I should have 5 roots total because that's the number of degrees I have. I have 1, 2, 3, 4, 5, so we know we're good. Now, factored form. What's -3 as a factor? X plus 3. -1 is a factor. X plus 1. 1 is a factor. X minus 1. And then what do I use for my last factor that will give me the quadratic or the imaginary roots? We use the what? X squared minus 2x plus 5. So we use the original quadratic, then we put the quadratic into the quadratic formula. Any questions on any of this? I know it's a lot of work, but honestly, it's nothing new. None of this stuff it should be new to you guys. It's just we're literally putting all of it that we've already learned together. The only relatively different thing that we had to do or learn was quadratic formula, but we took a whole day to go over that last Friday. That's why I did that, because I knew it would come back to haunt you. All right, any questions on that? All right, so don't forget you do have a group quiz on this tomorrow. And again, by group quiz, I mean your whole group is taking that quiz together. You only get one paper per group. All right. So, and your groups are the ones that you have currently. And Miss Davidson will be in here and I will give her the seating chart. So don't be trying to mess around with the groups. All right. I can also tell by whose names are on the papers. All right. Now, your homework for today, there is